Hello everyone, today I am going to discuss some of the important mathematical methods. So let's start with Cardan's method. Here we have given x cube minus 18x minus 35 equal to 0. Here you can observe that there is no x square term. So at first we have to assume x equal to u plus v. Then by cubing both sides, we apply the identity. And then by rearranging, we compare it with the given equation. So we got u equal to 6 and u cube plus v cube equal to 35. Then we substitute the value of v in u. So we got 6 by v whole cube plus v cube equal to 35. So for our easy calculation, we let v cube equal to y. Then we got a quadratic equation y square minus 35y plus 16 equal to 0. Then by solving this, we got the value of y as 27 and 8. Now the value of y is v cube equal to 8. Now we solve this, so we get v equal to 2 minus 1 plus minus I root 3. Since we got the value of u, we have to find the value of since we got the value of v, we have to find the value of u. Now from we got u equal to 6 by v. So by doing all the necessary calculations, we got the value of v and u. So at first we have assumed x equal to u plus v. Then by substituting the values, we got the following rules. Our second method is Euler's method. Given x to the power 4 plus 12x minus 5 equal to 0. Here you can see that there is no x cube term and x square term. So at first we have to let x equal to root p plus root q plus root r. So by squaring both sides, we get x square equal to p plus q plus r plus 2 into root pq into root qr plus into root rp. So by rearranging this and again by squaring both sides and using the identity, we get this. So by again rearranging, we compare it with the given equations to get pqr equal to 9 by 4, p plus q plus r equal to 0, and pq, qr and r plus rp equal to 5 by 4. Again we assume pqr be the roots of this cubic equation. So using relation between roots and coefficients, we can write it like this. Now the cubic equation having roots pqr will be y cube a1 by a0 y square plus a2 by a0 y plus a cube a0 equal to 0. Then by substituting the values of this, we get a quadratic equation. Then by solving the given quadratic equation, we get the values of p, q and r. So now we have to find the values of root p, root q and root r. So now we have to find the square root of these values. Here I have written this in rough, as you can see that. Now at first we assume that x equal to root p plus root q plus root r. So this will be the following combinations. So hence the roots will be 1 plus minus root 2y and minus 1 plus minus root 2. Our next method is transformation of equations. In these questions, we are given an equation and we have to find a new equation whose root will be 2 times of the given equation. So let us assume alpha be a root of this equation, and then according to the question we assume y equal to 2 alpha. Since alpha is a root of this equation, so we substitute the value of alpha, that is y by 2 whole square plus 5 into y by 2 plus 6 equal to 0. Then by solving this, we got our required solution. Now our next method is based on the relation between roots and coefficients. So here we are given 2x cube minus x square minus 18x plus 9 equal to 0 if two of the roots are equal in magnitude but opposite in sign. So at first we have to assume the three roots as alpha 1, alpha 2 and alpha 3. Then according to the question, alpha 1 is equal to minus alpha 2, that is alpha 1 plus alpha 2 equal to 0. So I can write that like this: alpha 1 equal to minus alpha 2. Then by using relation between roots and coefficients, the first relation will be a1 equal to a0 minus alpha 1 plus alpha 2 plus alpha 3. Then by substituting the values, we get alpha 3 is equal to half. Then our next relation will be selecting 2 at a1. Now a2 equal to a0 alpha 1 alpha 2 plus alpha 1 alpha 3 plus alpha 2 alpha 3. So by putting the values, we get alpha 2 equal to 3. Then our next relation will be a3 equal to a0, assuming 3 at a time, alpha minus alpha 1 alpha 2 alpha 3. So by substituting the values, we get alpha 1 equal to minus 3. So our required roots are 3, minus 3 and half. Next method is Descartes' rules of signs. Here we are given a problem: x to the power 4 plus 2x square plus 3x minus 1 equal to 0. So we let fx equal to this. So at first we can see that there is plus, plus, plus and minus sign respectively. So at first we can see that there is only one variation in sign, so only one positive root exists. Then again we find f of minus x, so we get x to the power 4 plus 2x squared minus 3x minus 1. Now we write the signs, that is plus plus, minus and minus respectively. So here also we can see that only one variation is there, so only one negative root exists. Also, if we put the value of f equal to 0, we get minus 1, so we can say that there is no 0 roots. So at last we can finally say that there are only 2 real roots and 2 complex roots with imaginary part not equal to 0. Now we will see how to solve this type of infinite series. Here we need to prove that all roots of these equations are real. So we are given this series. So at first we need to make this part as a natural number or a whole number. So we multiply both sides with x to get 1. Then we multiply with the negative sign both sides. Then we have added 1 on both sides, so it will add to this series. Now since it is an infinite series consisting of n terms, so in the right hand side part we get n. Now by taking LCM we get this. Now let us suppose that a plus ib is a root of this series, so a minus ib then also be a root of this series. Then by substituting the value of x as a plus ib and a minus ib simultaneously, we get 2 equations, as you can see. Now by subtracting both these equations we get like this in series. Again by taking LCM we get this. Now by taking common we can take common as minus 2 bi, then we are left with this series. Now we can say that since the bracket part is positive, as we are given that a1, a2, an are all positive integers, so this bracket part is positive, so we can say that b should be equal to 0. As b is equal to 0, that is, so the whole imaginary part of this root is 0. So since there are no imaginary part, so hence we can say that all roots will be real. Now we will see how to solve an equation which has 3 distinct roots of equal moduli. So at first we have to assume the roots. Now we should assume the roots like that. It will be easier for calculation. So we assume the roots as r, and r into cos theta plus minus I sin theta. One root real and other roots complex. So now we can, since they are the roots, so we can write like this: x minus r and x minus r cos theta plus I r sin theta, such that and multiply this whole term is equal to 0. Then by solving this we compare it with the given equation to get the value of r cos theta and sin theta. From that we can find the roots will be this r cos theta plus I sin theta, r cos theta minus I sin theta. So by substituting the values of r cos theta and sin theta, we get our required roots. Our next topic is metric inversion. So we need to find the inverse of this given matrix. So we should take the augmented matrix like this, A and I. Now we have to make this A part as an identity matrix, and whatever the matrix we will get, it will be our inverse part. Now at first we should do our operations to get A inverse, which I have shown like this. You can see that. Now we have got our A inverse. Now we can also verify it by multiplying A into A inverse. That will give us an identity matrix. Now we will see a problem of symmetric matrix. Here we are given alpha, beta, gamma are the roots of this equation, so we need to find the value of this. I will show 1 and 2 part. So here we are given this equation. So by using roots and coefficients, at first we need to take 1 each. So alpha, beta, gamma is minus a1 by a0, which is, by substituting this value, will be minus p. Then we are taking 2 at a time. Alpha beta plus beta gamma gamma alpha is equal to q. Then we are taking 3 at a time. So we get the value as minus r. So at first we need to solve summation of alpha squared. So summation of alpha squared can be written as alpha squared plus beta squared plus gamma squared. Then by using the identity we can write it like this: alpha plus beta plus gamma whole square minus 2 whole bracket alpha beta plus beta gamma plus gamma alpha. Then by substituting the value we get the solution. Similarly, here we are given alpha squared beta, so you can write that like this: alpha squared beta plus gamma squared alpha plus beta squared alpha plus beta squared gamma plus gamma squared alpha plus gamma squared beta. So by arranging this and by using the identity and then by substituting the values, we get minus pq plus 3r. At last we will see how to do the echelon form and from that how to find the rank of the matrix. Here we are given a matrix, so I have written the given matrix. So the first element will be the pivot element, as it is a non-zero element. So we have to make all the entries below each pivot 0 by using the operations as given here. You can apply any to make all these entries below each pivot 0. Then we should move to the next row and repeat the same step. Here we can see in the next row we have no pivot element, and then in the third row we get 1 as a pivot element. So I have replaced this R3 and R2 positions, and hence we got 2 pivot elements. So the non-zero rows will be 2, and hence the basic columns will be this, and also the rank will also be 2. Thank you everyone for your time during this brief explanation.